Another way to store data is by using a linked list. There are a couple different linked lists. We can have a singly linked list and a doubly linked list. But in this lecture and in this section, we are going to talk about a singly linked list. Now, unlike an array, which requires a fixed size, we can use a singly linked list, which can easily expand. The concept around a singly linked list is pretty simple, but with Rust's ownership and memory system, sometimes it can be a bit more complicated to create a linked list in Rust than in other languages. So let's take a minute to try and understand what a linked list is. So we'll say we have a node, and we'll say it is node 1, and we'll just give it a circle, that way we know it's a node, and we'll label it as a node. So inside of a node, we're going to have two pieces of data at least. So we can represent this as a struct, and we will say the name of the struct is node. And then inside of here, we're going to have our piece of data. So in this case, our data is going to be 1. And then we're also going to have something that is called next. So what next is next is going to store the information, so the memory address, to another node. So we'll say we have node 2. And we'll say node 1's memory address, memory adder, is 100 to keep it simple. This link right here is represented by the next value in our node struct. And then we will say our memory address for node 2 is 200. So next is going to point to this memory address of 200, and we know at that memory address is going to be this node that stores the value 2. So now we can point this node next value to node 3, and then we can point this node's value to another node 4, and then we have one more piece that we can point 4 to. So let's just go ahead and fill this out. So we'll say this is our next link, and we'll say this is memory address 300 and this is memory address 400. So currently what we have for node 1, if we looked inside of its struct, its data is equal to 1, next is equal to 200, which this points to node 2, whose data is equal to 2, next equals 300, and this is node 3, whose data is equal to 3, next equals 400, who now we point to node 4, whose data equals 4, and whose next equals, well, if node 4 isn't pointing to another node, which it's currently not, what would its next be? Well, in other languages, you would typically point this to something like null to denote that, hey, this is the head of the list. So in Rust, we don't have null, but what we can do is we can point it to none, because we can create an option inside, and it can either be some or none. So we can have it denoted as none. But now you heard me say that node 4 is the head. So we want to know where the head is in the linked list, because this is going to be the top of the linked list, which is going to be important for us when we want to add elements or remove elements. So node 4 is also going to have another struct, or excuse me, there's going to be another struct. And what we're going to have in this struct, and we'll just call this link, is going to be the head, which then will point to a link. And we'll see this, and this will be much clearer when we look at the code. But what this head is going to do is it's going to point to the top element in our linked list. So now that we have a general idea of how linked list works, let's begin setting up our own linked list. That way we can begin to see how the code starts to form. And we will begin doing that in the next lecture.